All right, so this is problem 2. A box falls out of an airplane that is traveling horizontally at 100 meters per second. The plane is at an altitude of 300 meters. Where does the box land relative to where it was dropped from? So read it one more time just to kind of try to remember all the details. A box falls out of the airplane and it's traveling horizontally 100 meters per second. So that means there's no initial velocity downward. The plane's at an altitude of 300 meters, and we want to know where the box lands relative to where it was dropped from. Okay, so that sounds like where does the box land relative to where it was dropped from? That sounds like it's really asking about displacement. So I'll make a really nice drawing of an airplane. Okay, and drops the box, and the box falls horizontally to the ground, right? And this will be the ground. And we know the plane is, what, 300 meters above the ground, so that means our displacement in the y direction is 300 meters. We don't know our displacement in the x direction, and our displacement in 2 dimensions looks like this. This is our displacement in 2 dimensions. And our initial velocity is horizontal. So I have a horizontal vector this way. That is 100 meters per second times t. So that's 100 t. That's my initial velocity times time. This one going down is so this should be a little longer. It's a little short. This is my 1/2 at squared going down. I don't know t, so I'll leave that alone. I'll call this 5 t squared, so that's half of 10 meters per second squared is 5 t squared. Okay. Let's see what we can figure out. Looks like we could find t pretty easily. Because 300 has to equal my 5t squared, right? This side and this side have to be the same length. Okay, so that means that if I divide by 5, I get 60 here, equals t squared. And so t is the square root of 60. I'm not quite sure what square root of 60 is, so I'll just calculate it. 60 square root 7.7. So t is going to be about 7.7 seconds. That's the time the projectile is in the air. That makes it easy to find displacement in the x direction. Is going to be 100 t. So that makes 100 t is 100 times 7.7, which is 770 meters. So that's the horizontal displacement. There's a lot of ways I could do the last part. I guess I'll just use Pythagorean theorem. So if this is 770 meters across there, all I need to do is delta r is going to be the square root of my 300 squared plus 770 squared. Is that right? Yeah. This side here squared plus that side there squared has to equal my delta r side squared. So I solve that for delta r. And let's see here. I'm going to use the memory plus button. So 300 squared, add that to memory. Okay, now let's see if that worked. Memory recall, yeah, okay, I'm good there. So I forgot what I did, so I'm going to clear memory again. So 300 squared, add that to memory. Now 770 squared, add that to memory. Now I'm going to recall memory and take the square root of all that is 826. So 826 meters. So that's the displacement. That's the two-dimensional displacement while the package flew through the air. The package flew 770 meters horizontally, and it fell down 300 meters vertically. And it was in the air for about 7.7 seconds. And that's about everything I could think of finding. Anyway, I hope that makes some sense. And thanks for watching. Hope you have a good day.